again. This is Wi-Fi Tech Lab channel. We are back with another topic. This is called Onstick Routing. Remember, we were configuring VLANs and tried to make them communicate using a dynamic routing protocol. In this case, we'll be using another method to actually communicate two VLANs using the on-stick routing. Okay, what you see right now, this is the lab that have one router, and this is actually the switch, which is the layer 2 switch. And on our left hand side we have the VLAN ID 10 and the network ID that we'll be using associated with this VLAN is 192.168.1.0/24. This is again class C IP address, and we have the default gateway that we'll be using as 192.168.1.1. This is for the local area network on the left hand side, and on our right hand side we have VLAN ID 20. This is on the same switch as the other switch. It's just that we have logically segregated or divided the interfaces on the switch into two groups. Okay, so we have the network ID 192.168.2.0/24. This is again class C IP address, and then we have the default gateway, which is gonna be 192.168.2.1. okay, now without wasting further time, let's just dive in and configure the VLANs on this switch. Again, as you know, the first thing that we need to do is to enable the switch and then type in the command config terminal, and then we can change the host name. In this case, we have changed it to switch 1. Now all I have to do is to create the VLANs. If you still remember how to create the VLANs, all you have to do is type in the command VLAN and then specify the ID of that VLAN that you want to create. In this case, if I press the question mark, it can tell me exactly the range at which I can use those VLAN ID. I will start from 1 up to 4094. Okay, and then as we move along, we will also talk about the extended VLAN. Okay, and also you'll find that they are VXLAN, but for now let's just keep it basic. We will be using VLAN 10 for this lab. Okay, so VLAN 10, and then let's give it a name. In this case, we'll just give any name. Let's just give it local stuff. Okay, this is just the name that I'll be able to see when I run the command to show VLAN. I'll be able to see this name. Let me maximize this so that you'll be able to see. This is the VLAN that I've created. It's VLAN 10, and then this is the name that I've just created and associated with that VLAN. This is the VLAN ID, and then the interfaces that are associated with the VLAN, currently it's none. Remember, by default, all of the interfaces on the switch, they belong to VLAN 1. This is a native VLAN, so all we have to do now, we have to associate all of these interfaces from 1 01 up to 5. All of these devices, they must be associated with that VLAN. So all I have to do is I have to come here and then specify the range at which I'm willing to associate those those interface with that VLAN. So I would have to type the command interface range FA0/1 up to 5. Okay, and then all I have to do is type in the switch port mode access. Okay, in this case, I will have to further type in the command switch port access, specify the VLAN that I'm willing to associate the VLAN with, the interface with. Okay, and then do right. Now if I type in the command to show VLAN, I'll be able to see exactly that these are the interfaces that I've added to this VLAN ID. Okay, and then if we go and check and look for those interfaces, they are no longer part of VLAN 1. Okay, now let's create another VLAN on the same switch, which is VLAN 20. All we have to do is to type in the command VLAN 20 and then give it a name, local staff maybe 2. Okay, this is just an example name, and then we have to do show VLAN so that we'll be able to see the status of all of those VLANs that are created. In this case, I have created another VLAN. This is VLAN 20. This one over here, staff 2. It is currently have no interface associated with it, so I will have to choose one of those interfaces that are still belonging to VLAN 1 as the native. Okay, so all I have to do now, I have to check all of my interfaces that I'm willing to assign to that VLAN 20. This is starting from 6 and it go to 10. Okay, so I can go back to my switch. This is layer 2 switch again, and say interface range FA0/. To be careful, we must start from this range from 6 up to 10. Okay, and then switch port mode. This is access. Switch port mode, switch port access VLAN 20. Okay, do show VLAN. Now you'll be able to see that actually we have associated those interfaces with VLAN 20. All right, now which means the devices on this VLAN, they can be able to communicate to each other. Okay, but they cannot be able to communicate on the other side. So we will have to create, or we will have to configure the Onstick routing so that we will be able to send the traffic across from one domain to another broadcasting domain. Okay, so all we have to do now, let me just make this okay, let's just leave it. So all we have to do now, we will have to enable this interface, but be careful this time. We don't have to let's just do this. We don't need to assign the interface. Remember, I mean the IP address on that interface. Remember, this is layer 2. We don't need to try and assign the IP address on that interface because this is a layer 2 switch. All we have to do now, we have to come here. Sorry about that. We will have to come here and say exit, and then because this is a trunk link, we will have to just select the interface and say interface FA0/11. Okay, and then switch port mode trunk. Okay, no shutdown. Okay, do right. Now this interface is a trunk link, but the status of this interface is currently down. If I run the command do show IP interface brief, I'll be able to see that fast 011 it's still down, even though I have typed in the command no shutdown. It's still down because the other side of the interface is down. All we have to do now is to move up to the router here, which is where we actually need to pay attention, because this is where we're starting to configure the Onstick routing. Okay, what do we need? We need to create the sub interfaces for each VLAN. Okay, so how do we do that now? Let's come here and type in no, enable the router config terminal, and then let's give it a host name. Let's just say R1 for now. Okay, host name R1. Okay, now the host name has been changed. All we have to do is to select the interface. We are trying to assign an IP addresses to these interfaces. Okay, this is the sub interface, so all of this traffic will be using the same link, or they will be using the same interface to send or to forward traffic to another network. Okay, in this case we will have to select the interface, which is fastnet 0/0. Remember, this is a trunk link, which means it is capable of encapsulating .1q tag. In this case, I will have to come here and say I'm willing to assign, or I'm willing to actually select this particular interface which belongs to VLAN 10. In this case, I will just select 10, and then I will have to specify that encapsulation .1q. Okay, this is the command that I need to type, and then I will have to specify again the VLAN ID that I need to assign the IP address into. Okay, all I have to do now is to assign the IP address as normal, and then type in IP at 192.168.1.1, and then I'll have to specify the subnet mask, which is 255.255.255.0, and then I will have to say no shutdown, just to be sure. Do right. Okay, now the interface has been assigned with IP address. The sub interface of that physical interface has been assigned with that IP address. This is the default gateway that we have used on the sub interface of this interface. Okay, now let's go to another interface. In this case, let's go to interface fa.0/0.20, because this is the VLAN that we are trying to access. And then all we have to do now is to type that command again, encapsulation.1q traffic, and then we need to specify that now this is VLAN 20, and we can start assigning that IP address of 192.168.2.1, and then specify the subnet mask of this class C IP address 255.255.0. No shutdown. If you pay attention, the interface is still in a shutdown state, because we are actually running this command no shutdown to the sub interface of that interface. The reason why this one is not coming up is because we have ran the no shutdown command on the sub interface, but not on the interface itself. So all we have to do now is to come here and run the command interface fa0/0, and then you will be able to see that the interface is going to come up. As you can see, now we have the interface status that says the link is up. Okay, we have successfully configured something called Onstick Routing. For now, this is a basic of how to configure the Onstick Routing. As we move along, we'll also touch upon the route maps. Okay, for now, let's try to assign or to try to configure the DHCP on this router, so that we won't have to come here manually and assign the IP addresses to all of these devices. To save time, let's just do this now. So all we have to do again, we have to type in the command ipdhcp pool, and then I will have to use any alias name. In this case, I will just say maybe for 10. Okay, and then I will just say network 192.168.1.0, subnet mask of 255.255.255.0. This is class C, and then I will have to specify the default gateway. In this case, I will just type in the command default router, and then specify the default gateway. In this case, we are using .1.1, 192.168.1.1. Now I can further use the DNS server by typing the command DNS-server, and then let me just use 8.8.8 for now, and then exit. Now if I go to these devices, I'll be able to obtain the IP addresses automatically. Okay, because now I have successfully configured what? I have successfully configured this router as my DHCP server for this local area network, and then also this interface is up. Let me just do this in all of these devices to make it more clear for everyone that we are trying to actually get the list from the DHCP server pool. Now let's do this also on this PC3. Now let me just simulate this so that you will see how actually this request is being done. Let's see. Now let's play it. Let's see. Okay. Packet is flooded to each and every, because now the switch doesn't know. Okay, it flooded the packet to each and every interface on this broadcasting domain. If you pay attention, it didn't flood the packet on the right hand side because this is the separate broadcasting domain and this is also the separate broadcasting domain. So what it did, it flooded the packet only to those interfaces except from where the packet of the DHCP request came from. Okay. Now, what you will notice, you will see that the device successfully obtained the DHCP IP. Okay. Now, let's move to this side and see if we are going to obtain. Obviously, we're not going to be able, we will get the APIPA. Why? Because we didn't configure any DHCP server on this network. Okay, in this case I would have to come in and type in the command DHCP pool. It's an alias name, so I can just say 20 network 192.168.2.0 255.255.255.0. Now we have to type in default router 192.168.2.1. DNS, we can make it 8.8.8.8. This is the Google DNS. Exit and then do right. Okay. Now that we have successfully configured the DHCP server, which points to this network segment, so they saying there is a DHCP IP conflict. Let's go back to, let's see if there is actually a conflict in here. Okay, let's see. Okay, well, there is no conflict. Let's see if we can just try to obtain all of these. As you can see, the devices, they are already have been assigned or given these list IP addresses. As you can see, we have all of those devices obtaining the IP addresses from the DHCP server that we just configured on the router. Okay. Okay, now let's test. Let's do the final test based on trying to send the traffic from this particular domain to another broadcasting domain. All I have to do, I have to run the ping, and then I will try to simulate it so that we will be able to see exactly how the packet moves when it touches those sub interfaces there, and then route the packet to the other side of the network. So I'll just say I'm trying to ping PC5 to PC0 on the left hand side, and then let's see what's gonna happen. The packet is actually leaving from PC5, and then the switch is flooding the packet to each and every interface on the broadcasting domain except from PC5 because it's received the packet from it. Okay, this is actually something called MAC learning, and then now it will send the packet again to router 1, and then from the router 1, and it will send directly to where it's supposed to go on the other side. Okay, it's gonna flood it on the other broadcasting domain now, and then as you can see, it's flooded to all of the interfaces on the broadcasting domain. And this PC0 actually is the one that said, okay, I have this particular MAC address, and then it's responding to PC5. Okay, now as you can see, when we go into command line interface and ping 192.168.1.1, you will be able to see that we can actually being able to ping the other network or the other device on the VLAN 10. Okay, so which means we can also ping, this is actually the default gateway of VLAN 10. Now let's ping the device that is located to VLAN 10. As you can see, this is pingable. Now let's ping another device. Okay, so basically there is no other PC that is using .3. The other one is just using .4. So let's ping, oh, there we are. So the first packet was dropped, and then the following packet is being received. Okay, so 4 were sent, and then 1 was dropped, and then 3 were received again. Now let's ping PC4. As you can see, also PC4 will be dropping the first packet, and then the other packet will be successfully, as you can see. Now let's try to break down whatever configuration that we did here on this router and see if we're still gonna be able to send the packet across. All I have to do is to come here and access the sub interface again. Let me just come to the 10, and then I'll type in the command. Let me just type in the command no IP at 192.168.1.1 255.255.255.255.255.0, and then I'll just say exit. Now let's see what's gonna happen after that. I will try to ping again on the other side and see if we're gonna get a response. Unfortunately, we're not gonna get anything because we have altered the configuration on the sub interface that was making it possible for us to send the packet or to make different VLANs to be able to communicate to each other. Okay, I'm just gonna restore this configuration so that you'll be able to see now that the packet actually continue to be sent across as soon as we bring back this configuration. So I need to access the sub interface first before I actually configure that IP. Okay, so I need to select the sub interface F0/0.10, and then the sub interface IP at 192.168.1.1 255.255.0. Okay, now if I come back here again and try to send that ICMP, as you can see, it becomes live and it's become successfully sent across between two broadcasting domains. I hope this video was so informative to you. Let's see each other on an upcoming video.